So, how much heat is required to convert this mass in grams of ice, which is at an initial temperature of 25 degrees Celsius, and we want to bring it to this final temperature of 65 degrees Celsius. And so how much heat total is required to do that? This is a very challenging question because you have to recognize that it's going through multiple changes. First of all, if we look at the heating curve of water, right? So here is where ice is, because this is the solid phase in this spot. So ice would be right about there. Okay, then 65 degrees is liquid water. It has to totally melt, and then here is where it's in the liquid phase, so 65 degrees could be right about there. So we'll call this negative 25 degrees Celsius. So you actually have multiple things occurring here. We are getting the solid to its melting point, right? And so that is point number 1. And point number 1, we're going to use Q equals MCAT to solve, right? And then the second thing that's happening is it's going to totally melt. That's point number 2. And so point number 2, we're going to use Q equals mass times the delta H of fusion to calculate the heat. And then finally, this is going to go from 0 degrees to 65, and so we're going to have to use Q equals MCAT for that last point as well. And so at the end, we're going to have to take each of these Q's and add them together. So call this Q1, Q2, Q3. And when it's all said and done, we're going to add Q1, Q2, and Q3 in order to get our Q total amount of heat. You do have to note that here it goes from negative 25 to this point, which is 0 degrees, and then here it's still 0 degrees when it goes to 65. So our change in temperature first is negative 25 to 0, and our other change in temperature is 0 to 65. So now let's start setting up our equations. Equation number 1, that's going to be my Q1, is equal to my mass, 447, times, and I need the specific heat of ice, which is in the solid phase. It's going to be 2.06. 2.06, and the change in temperature is going to go final is 0 minus initial is negative 25, and that's going to get me my first Q. Number 2 is Q2. That's going to be the mass, 447, times, and here is the delta H of fusion that's occurring. So I want to use 334 joules per gram for my delta H of fusion, and that'll be my Q number 2. And then finally, I'm going to get Q number 3, which is going to be the mass, 447, times the specific heat, and right here it's a liquid, so I need the specific heat of liquid, 4.184, times, and then the final temperature is 65, minus the initial temperature was 0, and that's going to get me my Q number 3. So now let's do the math for each of these. We have 447 times 2.06 times, and notice that 0 minus negative 25 is just 25. And so that's going to get me my Q number 1. This is 23020.5. Q number 2 is 447 times 334. That's going to get me 149298. And my final Q is 447 times 4.184 times 65 minus 0 is just 65. And that's going to get us 121566.12. And now to get my final answer, I want to add this plus this plus this. So when I take this plus this plus this, I get this grand total of energy that it's going to take to melt the solid, bring the solid to its melting point, melt it entirely, and then bring the liquid up to a temperature of 65 degrees Celsius.